Hello everyone, my name is Abdurrahman Fahim and I'm currently a third year PhD student at University of California, Riverside. And I'm shooting this video for the sake, to answer the two questions for the sake of the interview. So let's start with the first one. What is A/B testing? A/B testing is based on a statistical concept called hypothesis testing. And the hypothesis testing is as simple as this. You make an assumption and you want to test that assumption reality to actually measure if your assumption is correct or not. So let me give you an example to make the idea clear. Assume you are a chef and you make your favorite soup and you make an assumption saying, okay, if I add cilantro to the soup, it would be much better. I would like it more if it's worse if it is with cilantro. So that was the assumption. So now you want to test this. The easiest way to test that is that you make the soup, adding cilantro, and then taste it. If you like it, then your assumption is correct. If you don't like it, then your assumption is not correct. So it's hypothesis testing is as simple as this. Of course, this is a very naive example. Let's take it to a higher level. Let's take like a real practical problems with hypothesis testing. So assume you are the same chef and you're making your soup, but you have restaurants with thousands of people coming every day to take your soup. And you make an assumption saying, okay, if I add cilantro to the soup, my customers will like it better. So that was an assumption. That's an assumption, and you want to test that assumption in reality. You want to make sure if this assumption is correct or not. Because if the assumption is correct, then your customer will be happier, and that's something you want to do. As a chef, you want to make sure that your customers are always satisfied with your services. So what is of course you cannot test this on all the customers because this is very impractical and infeasible as well. You cannot bring all the customers to try your new soup and ask them about their opinion. This is very infeasible. You have tons of customers. That's right. It cannot be done. The other way, which is mostly common used in many applications, actually it's used a lot in real life, is called sampling. That meaning instead of doing of test the new soup over the entire population, or which in this case the entire customers of the restaurant, I will do just on a sample of them. I will just do it on 100 or 200 or like a sample of customers, and based on the outcome of this small sample, I can infer the outcome over of all the entire population. So now let's just based on this example, like I told you exactly what we do in practice, let's tie the concepts of hypothesis testing to this example. So the first concept, the first actually pillar of hypothesis testing is called population. So in that case, what is your population? Population in this case is the total number of or all the customers that come to your restaurant. This is the population. The second one is called the intervention. The intervention is actually the assumption that you make. The assumption is you make, remember it, is just if I add cilantro to the soup, my customers will like it better and will be satisfied with my service. So the intervention here is that if I add cilantro, it will be to the soup, it will be much better than the soup without cilantro. So this is the intervention. The third one is the comparison. This actually based on the intervention. This is the assumption. The comparison is that you compare the taste of the soup with cilantro and the soup without cilantro. So this is the comparison. And the last one is the outcome. The outcome is that you ask your customers, do you like it or not? Do you like it, or you prefer the older one, or you don't care? So based on this now you have completed your your hypothesis testing, and we have tied this to the concept of hypothesis testing. But now there are two questions of interest. The first one is, how do we select the sample? Like, on what basis do I select the sample on which I do my testing on? The second one is based on the outcome, the small sample? How do I infer the results of the entire population? Since the second one is much more like complex in a sense that it requires a lot of math, and I don't want to bring math in this short video. So let's tie ourselves to the first one, which is uh, how do we select the sample? So the sample should be randomized and it should not be biased. So let me give you an example. What could be the bias in that case? Well, the first common mistake that people do is called the covariance. They're adding variance that actually interrupts or actually like does not actually measure the outcome of the entire population. Let me give you an example. Assume that your restaurant is located in the United States and in China, let's say, and instead of doing random experiments, you just did was saying, okay, I will just do the I will try only the new soup in China. So, and based on the outcome, you inferred about the entire population. But this is wrong because you added the allocation variability. And this is wrong because people in China may have different taste from people in the United States. So, and then when the outcome of the results in China cannot be generalized all over the world. So that's just a simple example showing you that what's called the covariance might affecting it. Now you are adding the location while doing your experiment, and this is actually affects badly your experiment. Another mistake which people do is called statistical bias, or actually selection bias. Selection bias is basically saying, okay, I want to make uh, 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 um, I want to make a sample that actually covers my entire population. So I cannot, for example, take a sample from a neighboring restaurant. If I take a sample from a neighboring restaurant, that's nonsense because we are different. The people who come to my place is different from people who come to their place, and they do prefer different type of foods, different type of food. So I cannot get the outcome of neighboring restaurants and apply it to my restaurant because there are different population. So while I'm doing a selection of a sample, I need to make sure that's not biased. So that's all about the first question. Let's move to the second question, which is I think it's plotting libraries. So I've dealt during my research, I've dealt with different plotting libraries, like mostly Matplotlib and Pandas libraries. Like I did a lot of things. Mostly I'm dealing with PDFs and CDFs. This is mostly my work goes on. But I did actually an interesting experiment, which actually I likes a lot. I like it a lot. So I have a bunch of tweets and I want to show their location on a map. So for instance, if a tweet coming from Egypt, I want to show them in a map that this tweet coming from Egypt. And if a tweet coming from Saudi Arabia, I want to show in the map that this is coming from Saudi Arabia. So it's just, I have in practice, what I wanted that I want to have the world map and I want to show the tweets on those maps. So for that thing, for this application, I use what's called GeoPandas. GeoPandas, it's a very interesting library that have already implemented the layout of the countries, and you just give the countries, or you actually give the Cartesian coordinates of where you want to show your tweet or whatever you want. So in my case, I wanted to show like a map with tweets plotted on. So I'm converting the location, let's say Cairo or Egypt or United States into a Cartesian coordinates that can be plotted into a map. Um, and this is, I think, that's it. We're almost on time, so good. Thank you for watching. Uh, See you.